AP Chemistry students. Today we're going to be doing the next lab, the percent copper and brass lab that goes with our chapter 12 on solids. And I'm going to skip around a little bit. We're really not going to do the introductory activity. You've already done that in terms of dealing with figuring out the wavelengths and stuff like that. And for the guided inquiry activity, I'm actually going to do part B first, get that going with the brass, because it takes a little time for the BBs to dissolve in the nitric acid. And then while that's dissolving, then we'll come back and do part A so that we can make our Beer's law curve with the copper 2 nitrate. So what I have here is, here's my brass, which is just basically some BBs. Maybe if I can open it. Let me try a different container. Okay, so I'm just gonna add, was it 3 BBs? Three BBs, and I'm gonna go weigh them. Oh no, I've got BBs everywhere. Oops, they're, no. Oh, I lost one. Got the other ones though. Okay, so let's go weigh these. I've already got the balance zeroed out. So we'll go over here. All right, so it's already zeroed. And we'll weigh the BBs. I don't know if you can see that with the glare. So 1.4502. So it looks like the mass of the BBs are. Okay, then we'll take them back over here. And we're going to put them into a little beaker. And then we're going to go over to the fume hood to add the nitric acid. Now we actually did something similar to this in honors chemistry. If you remember the copper lab that we did, where we had copper wire instead of brass BBs, and we added nitric acid. So here's our about 5 milliliters of nitric acid. The reason why we have to do it in the fume hood, besides the fact that the nitric acid is concentrated, is it's going to make a brown poisonous gas. And you can already see the gas forming. Let me get, so all that bubbling is showing a gas. I'll even cover it so it kind of traps it. But look, all that brown stuff, that is nitrogen dioxide, very poisonous, not good. So that's why we need to do this in the fume hood, because we don't want to be breathing that. And I'll let that go. Okay, so while that's working its magic, and obviously that's very hot, I'm going to close the fume hood because I really don't want any of this escaping, since they fixed my exhaust fan. Awesome. Okay, so we'll let that continue to dissolve the BBs while we go back and do part A of the guided inquiry. All right, so let's go back over here. And so now we're going to dilute the copper 2 nitrate. This is 0.4 molar solution. So in the one, class just ended. The one, how much? Is the one that's the fully concentrated. We just need 8 milliliters of it. Oops, that's too much. Really doesn't matter. So this one has the full concentration of 0.4 molar copper 2 sulfate. And then, or nitrate, sorry, my bad, nitrate, copper 2 nitrate. Okay, then for the, we want one test tube to have 0.05 molar, so we just need 1 milliliter. And really, I probably should just use, well, let me get a pipette. I'm not gonna mess with the volumetric pipettes. Just don't feel like getting them out today, but all right, so let's add 1 milliliter of okay, and then we're going to add 7 milliliters of distilled water. You see that okay? Not really. All right, so here's our 0.05 molar. And we're going to do the same thing with our 0.1, no, sorry, yeah, that's 0.05. Okay, so then, yeah, for our 0.1, that's our next concentration we want. We need 2 milliliters of the copper 2 nitrate. There we go. And 6 milliliters of water. That should be a little darker. And then for, what's the next one? The 0.2, yeah, 0.2 molar of the copper 2 nitrate. We will add 4 milliliters of the copper 2 nitrate with 4 milliliters of water. Is this gonna be enough? There we go. And then 4 milliliters of water. All right, we'll put it in this test tube. Okay, there we go. So there is our various concentrations of copper 2 nitrate. And so what we're going to do with those is we're going to run them through the spec. And now, since we're using these, we're going to set it, really 630 is the best, but with the calorimeters, we're just, the closest one we have to that is 635. And the first sample, we want to set our blank and filling with water. You see all this? Okay. So I'm going to put the blank in and calibrate. Let's see, make sure you can see that. I thought these had little kickstands, but I guess they don't. Okay, so we are good. We have calibrated it. We're at 0% absorbance. All right, as long as I don't change my wavelength, I don't have to reset the blank. So now we'll run each of these samples through. Doesn't really matter what order. We'll do the 0.05. Oops, crap. Overshot that a little bit. Let me go get a chem wipe and clean that up. Don't want any getting into the machine. We want the sides clean. All right, so let's put that machine and see what we get. Okay, can you see that all right? So that is our, oops, try to get everything in here. So we have 0.123 for absorbance for the 0.05 0.05 molar. And we'll do the same thing, see if I can keep from overflowing this one. Here's the 0.1. Oh, there we go, that's a lot better. So 0.1. Okay, so there's our value for the 0.1 molar. This absorbance of 0.206. And then the 0.2 molar. That in there, there we go. Let's see what that says. So we got 0.421, and then for our final one, the full concentrated 0.4 molar. Let's see what that one says. All right, 0.930. Okay, so those are what you're going to make your Beer's Law curve with. Let me clean these up while you're recording those numbers. So you'll plot the absorbance versus the concentration to get a Beer's Law curve, and then we're going to do the same thing with the copper solution from the BBs. And that should fall somewhere on that curve. And remember, when you're doing your graph, make it big. Use your graph paper, use your axes, so that you can get a nice, large, easy to read graph. And then it'll make it easier to plot where the copper 2-nitrate is from the BBs. So let's go take a look at how the BBs are doing. All right, let's take a look. There's still a little bit rolling around in there, but for the most, oh, we still got, look at that, still got some nitrogen dioxide, so we don't want any of that. That means there's still some undissolved copper. Producing that, so just keep moving these around until we don't get any more of that. Don't feel like poisoning myself today. Although I'm not the most patient person, so I may not wait until this is completely dissolved. Supposedly it's supposed to be able to dissolve in 10 minutes. It's been pretty close to 10 minutes. Well, I say that's good enough. Okay, so even though we still have some BBs left, I'm going to add some distilled water to it. Okay, and now we're going to take this solution back over here. Let's get you set up there. Okay, and the next thing we're going to do is we're going to transfer this to a 100 milliliter volumetric flask. Without the BBs. Oops, sorry. Ah, no, I dropped the BB. Oh well. And then we're going to fill it the rest of the way. Sorry, it's really challenging to try and make sure it's on camera. Okay, and now we're going to fill it to the line here. This is 100 ml, this will be 100 milliliter total volume. So we've got that set up. Let's mix it. The BB actually will help mix it. Can you hear that? Okay, now I haven't touched anything with the colorimeter, so we don't have to reset the blank or anything. It's still good to go. And now we're just going to pour some of this. So this is our BB solution. Let's put that in. And then we can record the value. So the absorbance for the BBs is 0.198. All right, so what you'll do is you're going to, after you make your calibration curve, your Beer's Law curve with the 4 diluted solutions, you will plot the BB concentration, the copper 2 nitrate from the BBs, on that curve to figure out what their concentration is. All right, so hopefully you enjoyed that. No, it's not as enjoyable as doing it yourself, but this is a really good lab, and usually people get good results. So finish that, working on those results and be ready to turn it in next week. Have a good day. Bye.